What's up, Chem peeps? Who is ready for a thriller of a free response? It's a short one, sort of. When heated, calcium carbonate decomposes according to the equation above. Boom! In a study of the decomposition of calcium carbonate, a student added a 50.0 gram sample of powdered calcium carbonate to a 1.00 liter rigid container. The student sealed the container, pumped out all of the gases, and then heated the container in an oven at 1100 Kelvin. As the container was heated, the total pressure of the carbon dioxide gas in the container was measured over time. The data are plotted in the graph below. Boom! The student repeated the experiment, but this time, the student used a 100 gram sample of powdered calcium carbonate. In this experiment, the final pressure in the container was 1.04 atmosphere, which was the same final pressure as in the first experiment. Oh my goodness! Subpart A. Calculate the number of moles of carbon dioxide gas present in the container after 20 minutes of heating. Alright, not gonna lie. Initially, when I looked at this problem, I was a little confused. I was trying to do stoichiometry, I was looking at the 50 grams of calcium carbonate, the 100 grams of calcium carbonate, but then I realized we've got an equilibrium reaction, and regardless of how much calcium carbonate I start with, I end up with the same amount of carbon dioxide. I know that carbon dioxide gas occupies a 1.00 liter volume, it's at 1100 Kelvin, and exerts a pressure of 1.04 atmospheres. So although kind of hidden, this is just our good friend Pivnert. Pivnert. 1.04 atmospheres, 1.00 liters. We're looking for number of moles. Because we're in atmospheres, we're going to be using the 0.0821 liters times atmospheres per mole Kelvin. And our temperature in Kelvin, 1100. Boom! Let's just jump on over to our good friend calculator. 1.04 times 1.00 divided by 0.0821 is divided by 1100. Answer. Number of moles, 0.0115 moles CO2. Boom! Subpart B. The student claimed that the final pressure in the container in each experiment became constant because all of the calcium carbonate had decomposed. Based on the data in the experiments, do you agree with this claim? Explain. Alright, let's recall. In the first experiment, we added 50.0 grams of calcium carbonate, heated it up, repeated that experiment, but this time used 100 grams, heated it up. Each time, the final pressure in the container was 1.04 atmospheres, or as we calculated in part A, 0.0115 moles of carbon dioxide was produced. Well, if we had 50.0 grams calcium carbonate, like we did in that first trial, let's use some stoichiometry to determine how much CO2 would have been produced if all 50.0 grams of this calcium carbonate had decomposed. 50.0 divided by 100, 0.09. Answer. Well, if that were true, we would have gotten 0.500 moles carbon dioxide gas, which we just decided in part A that we didn't get. We only got 0.0115 moles. So, do not agree with students' claim. Now, let's be sure to explain. If the reaction had gone to completion, 0.500 moles CO2 would have been produced. From part A, only 0.0115 moles CO2 was produced. Thus, the claim is false. Nice try, student. Nice try. Now, you could also answer this question simply by realizing that the final pressure in both experiments, despite starting with different amounts of calcium carbonate, is the same. Therefore, we must reach some sort of equilibrium, and not all of the calcium carbonate is used up. Either way, just be sure to answer, explain. Part C. After 20 minutes, some carbon dioxide was injected into the container, initially raising the pressure to 1.5 atmospheres. Would the final pressure inside the container be less than, greater than, or equal to 1.04 atmospheres? Explain your reasoning. The final pressure would equal 1.04 atmospheres. Answered it. Now let's explain. Equilibrium was reached in both experiments. How do we know? We achieved a pressure of 1.04 atmosphere in each of the experiments, and the equilibrium pressure was determined to be 1.04 atmospheres. The reaction will shift to the reactant side, and the amount of CO2 will decrease until the equilibrium pressure of 1.04 atmospheres is reestablished. Boom. Le Chatelier. Subpart D. Are there sufficient data obtained in the experiments to determine the value of the equilibrium constant Kp for the decomposition of calcium carbonate at 1100 Kelvin? Justify your answer. Yes, there are sufficient data. Answered it. Let's explain. Kp equals the partial pressure of CO2 for this reaction. It's the only gaseous or aqueous species in this equation. Therefore, it's the only thing that's going to be included in our equilibrium constant expression, Kp. Since the equilibrium pressure of CO2 is known, we also know the value of Kp, 1.04. Boom. Done.